Okay, this is lesson 2.7 and 2.8 video. Right now, students are picking one of the two warm-up problems to complete with an algebraic 2-column proof. So I told them they could choose either to do this one, number 1, or this one, number 2. I'm going to give them a couple minutes. I'll go over both of these. A little review over 2.6. About one more minute. Okay, I will go over number 1 first. So remember, our first step is we always have to state what's given to us. So 5y minus 1 over 2 is the same as 7. And we're trying to prove that y is 3. All right, next step. Think if you're just solving this equation for y, you should times both sides by 2. That's our multiplication property of equality, which would give us 5y minus 1 is 14. That'd be subs, because you're substituting in something that's the same thing, such as 7 minus 2 is the same thing as 14. Next step, add 1 to both sides. Additive property of equality. Simplify that. 5y is 15. That'd be subs. Divide both sides by 5. Division property of equality. And we get y is 3, which is what we were trying to prove. Oopsie. Why did that erase? Why? Okay, y is 3. Proven. Next one. Now, there's a couple different ways you could have done this one, but your first step would be state that it's what's given to you. So that equation's given. And then everybody's second step should have been the distributive property. And we should have gotten it negative 8w minus 8 equals negative 5w minus 50. Okay, here's the part where we may differ. Those of you that did this one, raise your hand if you added 8w to the right-hand side. Okay, that's what I did too. I like to keep my variables positive. Did anybody add 5w to the left-hand side?
I did that on a different step. Like, I did different stuff. Wait, no, I didn't. I lied.
Okay, no worries. Lauren did? Okay, that's actually probably going to make the proof a little shorter if you choose to do that. But that's what I did. I added the 8w, which that's just my additive property of equality, adding something to both sides, simplifying is my subs. So then I got to here, and then I added 50 to both sides. Now you're just basically taking off your layers around your variable. Additive property, subs, we get 42 equals 3w. Okay, divide both sides by 3. Division property, and I get 14 equals w. Now, what I was trying to prove is that w equals 14. And right now I have 14 equals w. So we'd have to do this one step further if we ended up like that, using our symmetric property, that would be the same thing as w equals 14. Okay. How'd we do? That's review over 2.6. Okay, so we're combining this lesson into 2 again, kind of like we did for 2.4 and 2.5, because 2.7 is super, super short, and 2.8 is pretty short too. We'll get through all the notes today. Tomorrow, you have a quiz over 2.4 and 2.5. So at the end of class, I'll give you a little optional review sheet again. And then Monday, because we're at the end of chapter 2 already, Monday we'll do a quiz over 2.6, algebraic proofs, 2.7 and 2.8. With our chapter 2 test currently scheduled for Wednesday. That's just a little heads up on what's coming your way. Okay, so what we're gonna do today, you've actually done a lot of this stuff in chapter 1 already. Kind of like in 2.6, you solved equations before, and now we're just adding in the justifications and the postulates and theorem. A lot of this is what we did in chapter 1 with vertical angles, supplementary and complementary angles, but now we're just kind of adding in these justifications. But here's the good news. There's only two column proofs we have to do today. And we're going to start with one of them. But first, let's look at some of these properties. So these vocab words sound familiar. We have reflexive, symmetric, and transitive. And we talked about those in the last lesson. But now we're applying it to segment congruence. Segment congruence. So the reflexive property says any line segment is congruent to itself. Symmetric, if segment AB is congruent to segment CD, then we could flip-flop the order we say that in. CD, line segment CD would also be congruent to line segment AB. Okay? Just like we did with the properties of equality. Transitive, if segment AB is congruent to segment CD, and CD is congruent to EF, then we could say those two, AB and EF, those line segments would also be congruent. Okay. Here's another thing we've also used before in chapter 1 is this segment addition postulate. If we know a point's in between a line segment, we know that kind of separates our line segment into two segments, not necessarily equal unless it's the midpoint, but we know that we could take those segment measures, add them together, and that would give me the length of the total line segment. Okay, so right here, AB plus BC would be AC. That's technically the segment addition postulate. Again, math you've done before. Here's a postulate that allows you to justify that you can do that. Okay? All right, so here's one of our 2 column proofs. Here's what's given to us. This picture, and T is the midpoint of line segment SU. All right, just like before, whatever is given to us, we have to restate. So T is the midpoint. Of line segment SU. And that is given to us. Okay. What do we know about midpoints? If T is the midpoint, now think of relating this to the segment. What is true about segment ST and segment TU? Gwen. They are congruent. So I'm going to mark it up here, and I'm going to state that. I know line segment ST is congruent to line segment TU, and your justification can be definition of a midpoint. Okay. Definition of midpoint. Now, look where we're trying to go. We're trying to prove that x is 5, or that x equals 5. And right now, I'm like, okay, I have this kind of like a little math equation almost. It's a little congruent symbol, and I know that ST is the same as TU. Look what else is kind of given to us in our picture here. They're telling us what the length of ST is. What is the length of ST? It's 7x. We're also kind of given the length of TU, which is 3x plus 20. And since those are congruent, those lengths would have to be the same. What we really just did there, guys, we just did a little substitution. We just substituted in 7x for the length of ST because that was given to us. So our justification can be subs. Okay, from here it's just a little algebraic proof. Okay, now we just got to solve for x. So I minus 3x from both sides. Subtraction property of equality. We get 4x equals 20. That'd be subs. Two more steps. Divide by 4. Division, property of equality. And we get x is 5. And again, that's what we were trying to prove. So we're done here, and that would just be subs for the justification. Okay. So some other examples they might be asked there, like maybe you're not given the midpoint, but maybe you're just given that point T is in between S and U, and then you could just use the angle, or not the angle, sorry, the segment. We're going to do angles next. The segment addition postulate that this plus this would be the whole thing. Okay, but that's all 2.7 is segment segment relationships. Okay. 2.8 is angle relationships. So let's talk about some properties, postulates, and theorems with angles. Okay, here's these 3 words again: reflexive, symmetric, and transitive. So this would apply for angles as well. Obviously, angle 1 is congruent to itself, any angle. Symmetric. If we know angle 1 is congruent to angle 2, then angle 2 is also congruent to angle 1. We can flip-flop that. Transitive. If angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, then 1 would have to be congruent to angle 3. All right, here's another postulate that you've used before in chapter 1. We know if we have one big angle here, like ABC, if I'm looking at this picture in our notes here, if I have a ray and point D is in the interior of this angle, it's going to split this up into 2 angles. Angle ABD, which they're calling X degrees, and angle CBD, which they're calling Y degrees. Angle addition postulate, I know that I could add those together and get the whole angle, right? I know that this degrees plus this degrees would have to be the whole. Okay, that's called the angle addition postulate. Again, done this before. That's the postulate you've been using. Try an example. Find the measure of angle 1 if measure of angle 2 is 58 degrees and measure of angle JKL is 162 degrees. It's not asking me to prove anything. It's not asking me to justify each step. So we don't need to do a 2-column proof here. Okay? We're just going to kind of just notate off to the side technically what postulates we're using, but we would tackle this just like you guys did in chapter 1. We know the measure of angle 2 is 58 degrees. And we know the measure of JKL, which is this big one, is 162. So if I want to find the measure of angle 1, I could think, well, if I add 58 degrees to that, it's going to total 162 degrees. And technically, folks, just make this little note off to the side, because the question might be phrased of, hey, if I have this picture and I write this first step, what's my explanation? What's my reasoning? How can I justify this step? This would be the angle addition postulate. That these 2 angles would sum up to the big angle. All right, again, doesn't say we have to justify. We don't have to prove anything, so we can just do some algebra here. We get the measure of angle 1 is 104 degrees. That's all we got to do. Okay. Let's do one more. This time, I'm given that the measure of PQR is 102 degrees. And they want me to find SQR, the measure of SQR, and the measure of PQS. Okay. Who can set up the equation for me? Raise your hand. Alex?
You would do 9x plus 11, which is SQR, plus 7x minus 5, which is SQP, is equal to 102.
Perfect. I hope the microphone heard you because you said that beautifully. She said, let's add SQR, which is 9x plus 11, to PQS, which is 7x minus 5, and that has to total 102. What did you just technically use, Alex?
The angle addition.
Yep. Angle addition postulate. Good. Okay, so let's solve this. I have like terms 16x plus 6 equals 102. Feels good just to go back to old school algebra where I don't have to write out what I'm doing. They just trust me that I know. We get x to be 6. However, we are not asked to find x. We're asked to find the measure of SQR, which is 9 times x plus 11. So we know x is 6. $65 degrees. 2 ways we can find this one. We know they have to total 102. So we can just do 102 minus 65. Or we can plug 6 in for x here as well, if we'd like to. I'm just going to quick do subtraction. So this one's PQS would be 102 minus 65. Which gives me 37 degrees. Okay. What great fun. Questions? Okay. We're going to look at a couple theorems next. And again, technically you've been using these theorems in chapter 1. So we have the supplement theorem and the complement theorem. Supplement theorem states, and look how this is formed in an if-then statement. If 2 angles form a linear pair, if that hypothesis is true, then they are supplementary angles. We can conclude that. Which means those 2 angles total how many degrees? If they're supplementary. 180. Thank you. Complement theorem. If the non-common sides of 2 adjacent angles form a right angle, like this photo, then the angles are complementary, meaning the measures of those 2 angles total what? 90. Yep. Okay. Talked about this before. The diagram shows 1 square for a particular quilt pattern if the measure of BAC is the same as measure DAE, and they're both 20 degrees. Let's label that. And BAE is a right angle. Find the measure of CAD. Okay. I'm just going to call this X for sake of setting up an equation here. So I see I have 20 degrees. I have that angle BAC plus CAD, which is X, plus DAE, which is 20. Now, because these all form a right angle, what are they going to total? 90. And that's technically by complements theorem. I often abbreviate theorem like this. THRM. So if you ever see that, that's short for theorem. Okay, let's quickly solve this. We get x to be 50. And because that's what we called angle CAD, we called it x, that angle would be 50. Told you you'd like this lesson. Basically stuff we've already done before. One more, similar to this. If measure EFH is 2x plus 2, and the measure of HFG is x plus 1, find x and all three angle measures. All right. Well, in order to solve x, I need to set up an equation. And I see that EFG is a line, which means those two angles form a linear pair, which meets the hypothesis of my supplements theorem. They form a linear pair, so I conclude they're supplementary, so I conclude that they total to 180. Okay. So we get 3x plus 3 is 180. We solve this quickly. We get x is 59. That was one thing we want to do, find x, did that. Now I got to find all three angle measures. So I'll start with my blue one here, EFH, which is 2x plus 2. X is 59. Somebody crunch that one number for me, please. $120, thank you. Okay, folks. Quick math here. What would the measure of EFG be then? 60, right? That's total 180. 60. Don't even need to plug in our equation. Now that third angle they're talking about is angle EFG, our straight angle there, and our straight angle is obviously 180. Oh, we're almost done. One more page. Time flies when you're having fun, right, Cole?
Yeah.
All right, 3 more theorems we got to talk about. 3 more. Now, these ones are technically new for you, but it's pretty much common sense, okay? If we know that angles are supplementary to the same angle, then those angles have to be congruent, okay? That's what this congruent supplements theorem is saying. So look at my picture over here. If measure of angle 1 and measure of angle 2 total 180, and measure of angle 2 and measure of angle 3 total 180, then angle 1 and angle 3 would have to be congruent, right? Because you're using that measure of angle 2 to add to both of them to total 180. All right, and then the same thing works for the complements for totaling 90. So this picture, if the measure of angle 4 and measure of angle 5 total 90, if they're complements, and angle 5 and angle 6 are complements, meaning their measures total 90. Since you added the measure of angle 5 into both of those, angle 4 would have to be congruent to angle 6. So angles complementary to the same angle are congruent. Congruent supplements, congruent complements theorem. My third one, which we've talked about this one before, vertical angle theorem. If two angles are vertical angles, then they are congruent. What are vertical angles? Who can remind us? Vertical angles. Lauren?
They have the same vertex.
They share a vertex. I like that. They're formed by two intersecting what? Lines. Two intersecting lines. Lines always intersect at a point. Good. They share a vertex. And they're directly like across from each other. All right, so in this picture right here, angle 1 and angle 3, those are vertical angles. They would be congruent. Angle 2 and angle 4 would also be congruent. Vertical angles are congruent. Again, we know this. Here's a theorem, and I like this because it puts it in an if-then statement. It fits in with our proofing unit. All right, let's try one example. This is a pretty simple vertical angle example here, but do I have two intersecting lines in this diagram? Yes. 3x plus 1 and 148. What's their relationship? They're vertical angles, which means their measures are congruent. So we know 3x plus 1 is the same as 148 degrees. Technically, we can state that by the vertical angle theorem. All right, they just want me to find x. No problemo. 49. Those are pretty simple vertical angle ones. I give you a little more challenging ones on the homework because I don't want to bore you. I'm already putting Siler to sleep, so gotta keep it interesting. All right, we're gonna end with a good old two-column proof. And look how this is stated a little bit different in the directions here. I'm gonna give you a heads up. This is a 11-stepper, so right small. So this one states, oh my gosh. There we go. If angle 1 and angle 2 are vertical angles, and the measure of angle 1 is d minus 32, and the measure of angle 2 is 175 minus 2d, find the measure of angle 1 and measure of angle 2. Justify each step. There's that little piece that's saying we got to do a two-column proof here. I have to justify each step from the information given to me to find these two measures. All right, so first we're going to state what's given to us. Now, there's a lot given here. First, we're given angle 1 and angle 2 are vertical angles. I'm going to state everything that's given to us in step 1. We're given the measure of angle 1 is d minus 32, and we're given the measure of angle 2 is 175 minus 2d. All of that, folks, is given. Okay. Now, since angle 1 and angle 2 are vertical angles, since that's given to us, what can we say about angle 1 and angle 2? They're congruent, and that's what our second step is going to be. Angle 1 is congruent to angle 2 by the vertical angle theorem. Okay. Now I need to kind of get like an equation here. And what I'm trying to find is the measure of these two angles. And right now, all I know is that the angles are congruent. So since the angles are congruent, that means the measure of these angles are going to be what? Equal, the same. Yep, they're going to be equal to each other. And that's just the definition of congruency. That's what congruency means. I'm just having quite the time here. Okay. Now look what was given to us. Measure of angle 1 is d minus 32. I'm going to substitute that in there. Measure of angle 2 is 175 minus 2d. Substitute that in there. And our fourth step here, and that'd be subs. And then from here, it's just algebra. So we'll do all those like algebraic steps like we did in 2.6. Okay, I'm going to kind of do this quickly because this is review. Add 2d. Additive property of equality. Subs. Can we simplify it? Stay with me. Stay with me. Add 32. Simplify that with subs. Almost done. Divide by 3. All right. So we solve that algebraic equation for D, and we get 69. But we're not done, because what were we actually trying to find? Measure of angle 1 and measure of angle 2. So my 11th and final step here is to state what the measure of angle 1 and the measure of angle 2 are. Now, if you need, you don't have to like show your work in the proof, but if you need to show your work here, we know measure of angle 1 is D, which is 69, minus 32. So we get 37 degrees, which means the measure of angle 2 is going to be what? 37. They're vertical angles. They're congruent. They have the same measure, 37 degrees. And then we can just use subs there because we technically substituted in 69 into our equation to get that. Wow. That was our last notes for chapter 2. Thank you for being with me today. I'm going to stop my recording.